All right. So let's start. We are on question 14. Well, then did we do number 13? Sarah buys a sweater? Oh. Okay, you know what? We must have finished at 12. $7.50? Did you figure that out on your own? Because I don't remember doing that with you guys.
I think we did it in our other class.
Yes, we did do this when we were doing the review before. See, you pay attention to me. I knew it. All right. So just in case I didn't go over it in this class, we will start at question number 13. Let's see. Make sure I can see the paper. All right, so you guys can see my paper? See the math? And then Anaya, if you will help me, and DeMarcus, help me with the chat if I miss something. Unmute, let me know. They can't see the chat with both cameras going. I feel like you guys probably responded because I heard the little ding, but I don't know.
Don't worry, stay up.
All right, so question number 13. Sarah buys a sweater at a department store. The sweater costs $30. All right, question 13. All right, so the sweater is equal to $30. The store is having a 25% off sale on everything. 25% sale. So enter the amount of money in dollars Sarah saves from the sale. Do not consider sales tax. All right, so we need to figure out how much she saves, right? Not how much she's going to spend, because that's two totally different answers.
Sorry to interrupt.
Yes,
the
no
piece
problem.
of paper is a little blurry.
Oh, it is? Okay, thank you for letting me know. How's that? Good? Or still blurry? All right. I'm going to take that as it's good. All right, so Sarah, we need to figure out how much she saves, not how much she spends, right? Because if we are trying to figure out how much she spends, we're going to subtract the amount that she's going to save from $30. So this equation is going to be a little bit simpler than how much is she going to spend, because we just want to know how much she's going to save. So this is just a multiplication problem, okay? And figure this out by turning 25% into a decimal point, right? And whenever you have a percentage, right, you know that it's going to be out of 100, right? It's just like a test. If you get 100%, that means you got them all right. So if I need to find the percentage of 25% to turn it into a decimal point, it's pretty easy. 25% just literally means 25 out of 100, right? If she was spending 100% of the price of the shirt, right, it would just be full price. That's why it says 100, but we are going to be taking it off 25%. So 25 over 100 is equal to 0.25. To figure out how much she's going to save, I just need to take $30, right? And then I'm going to multiply it by the discount, which is 25%. That's 30 times 0.25. Without a calculator. Okay. Okay. Hey guys, I can hear all the like bleeps. And you guys are chatting a lot. All right, so 5 times 0, I've got 0. 5 times 0, 0 again. 5 times 0, 0. 5 times 3 is 15. Okay, 0, right? Because I'm going to the second line. 2 times 0 is 0. 2 times 0 is 0. 2 times 0, 0. 2 times 3 is 6. Now I have essentially 2 zeros, but I don't need to figure out what this is going to be because if I go across, I know that that's going to just be all zeros, right? 0, 0. Multiplication, I add these all up. 0, 0, 0. 5 plus 0, 0, that's 5. 1 plus 6 is 7. All right, so the trick, a little bit of practice. Remember I told you guys we figure out where to put our decimal point by checking to see how many numbers we have behind decimal points in the original problem. So I have 1, 2, 3, 4. So that means I need to go 1, 2, 3, 4, and I place my decimal point here. So that means I have, and this is going to be a dollar amount, right? And we don't technically see dollar amounts with that many zeros. So the dollar amount is going to be $7.50. And let's say you forgot the rule. You looked here and you kind of forgot, and you're like, oh, there's 2 numbers behind the decimal point. Obviously, if I go 1, 2, I can't save $750 on a $30 sweater, right? So make sure that your answer makes sense. My answer for the amount of money saved on a $30 sweater when there's a 75% off sale is going to be $7.50. Okay, so you're going to enter in here $7.50. Okay. So now we're going to move on to question 14 if there aren't any questions. All right, question 14. And hopefully you guys are all talking about math and not music. All right, number 14. So an electrician is hired to install outdoor lighting. The electrician claims that the relationship between the number of hours worked and the total work fee is proportional. Remember we talked about proportional, meaning that we can find a relationship between the two numbers. All right, so the fee for 5 hours of work is $225. Select all combinations of values for the electrician's work hours and total work fee that support the claim that the relationship between the two values is proportional. So we know that if he works 5 hours, right, he will charge $225. I'm going to write it this way just because I like the math for this better, right? So 225 for 5 hours. We can figure out how much he charges per hour, right? If I do 225 divided by 5, that will tell me how many or how much money he charges per hour, right? So let's see, 225 divided by 5. Five goes into 2, 0 times. Drop that 2. Drop that 2. 5 goes into 22, 5, 10, 15, 20, 4 times. 5 times 4 is 20. Drop that 2. There we go, sorry. So now I need to 225, drop this 5 down. 5 goes into 25, 5, 10, 15, 20, 25, 5 times. All right, 5 times 5 is 25. That means I have 0 left over. So there's no decimal, right? Goes in an even amount of times. That tells me that the proportion that we have, the proportional rate, is going to be $45 for every 1 hour that he works. All right, so in the question, it says select all combinations of values for the electrician's work hours and total work fee that support the claim. So now that we know how much he charges per hour, all we have to do is plug in the numbers for the answers given and see if they work out, right? So first one says 6 hours and $270. So if he charges $45 an hour and it says 6 hours, all we need to do is 6, right? 6 hours. We need to multiply the top by 6. 45 times 6, what does that equal? That's 6 times 5, that's going to be 30. 6 times 4 is 24 plus 3, 270. Okay, so if he works 6 hours, according to this, he should charge 270. So that means that our first value here, our first answer, that's going to be correct. So I'm going to, since it says select all combinations of values that are proportional, mark them. I'm going to go ahead and I'm going to try the next one because it doesn't say find which one, right? So my next possibility is going to be 6.5 and 315. If I look at that already, the difference between 270 and 315 is going to be $45. If he charges $45 an hour, but it says right here 6.5 hours, I know that that can't possibly be correct, right? Because that means he would be charging for a full hour for that half hour, right? I'll show you the math for that. If I have 6.5 times $45, 5 times 0, that'll give me 0. 5 times 0 is 0. 5 times 5 is 25. Carry the 2. 5 times 4 is 20. Plus 2, I've got 22. Drop a 0. 6 times 0 is 0. 6 times 0 is 0 again. 6 times 5 is 6. I'm sorry, 5, 10, 15, 20, 25, 30, 35. I lied, it's 30. 6 times 4 is 24 plus 2 is 26. That's 0, 0, 5, 2, 8 when I do 2 plus 6, and 2. Now I need to find where my decimal point goes. I have, remember my trick, 1, 2, 3 numbers behind the decimal points. I add up all the numbers for both values. So if I have 2 decimal points, I need to take into account the place that I have here. 5 is one spot. The 0 and the 0 are both 2 more, so I have to go 1, 2, 3 over. He's going to charge $282.50 for 6.5 hours. So we cannot mark 6.5 and 315. All right, my next value says 8 hours and 360. That means I'm going to multiply $45 by 8. Eight times 0 is 0. 8 times 0 is 0. Small 0, huh? 8 times 5 is 40. Carry the 4. 8 times 4, 8, 16, 24, 32 plus 4, 36. I already put my decimal point. Then I'm going to double check to make sure that I have it correct. I have 1, 2 numbers behind the decimal point here. I didn't put a decimal point over here. So I have $360 for 8 hours. All right, and those match. So I'm going to keep I'm going to mark 8 hours and $360. Evie, the code, let me see if you made an account. Okay, here's your user ID, Evie, and then the password is just whatever you made it out to be. And I can reset it. Let me know if you need me to reset your password, Evie, okay? All right, so now I'm going to check to make sure that my next values match, since I am charging, I know he's charging $45 an hour. I have 45 times 8.75. 5 times 0 is equal to 0. 5 times 0 is 0. 5 times 5 is 25. Carry the 2. 5 times 4 is going to be 20 plus 2. Okay, next value I have 7 times 0, 0. 7 times 0, 0. 7 times 5 is 35. 7 times 4, 28 plus 3, I have 31. Then 8, I have 8 times 0, 0, 8 times 0, 0. 8 times 5 is 40. Carry the 4, 8 times 4 is 32 plus 4 is 36. Got 0, 0, 5. 2 plus 5 is 7. 2 plus 1 is 3. 3 plus 6 is 9. I have 3. Okay, and now I have 1, 2, 3, 4 numbers behind my decimal point. So I need to go over 1, 2, 3, 4. So he's going to charge $393.75 for 8.75 hours. And this says 380. So I'm not going to mark that as the correct answer. So far I have 6 hours and 270, 8 hours and 360. And my last one to check is going to be 9.5. So I'm going to multiply $45 by 9.5. You're going to log in with the user ID. See, where did I put it earlier? Sorry, we chat a lot in this class. Here we go. Use this link to log in. Or scroll down and use user ID and password because you don't need to put in your whole email. It is just yours. Your login is just what I put right here in the chat, GEVEE. Perfect. All right, so 45 times 9.5. I've got 5 times 0, 0, 5 times 0, 0, 5 times 5 is 25. Carry the 2, 5 times 4, 20, plus 2. Drop a 0. 9 times 0 is 0, 9 times 0 is 0. 9 times 5 is 45. Carry the 4. 9 times 4 is 36, plus 4 is 40. 0 plus 0 is 0, 0 plus 0 is 0. 5 plus 0, 5. 2 plus 5 is 7. 2 plus 0 is 2. And now I've got 4. I have, for my decimal point trick, so I guess can't see all that, huh? 1, 2, 3 numbers. So I'm going to go over 1, 2, 3. I should have 3 numbers behind the decimal point. And I know for money, I don't usually see $427.50 with the 3 spaces back there, just 2. Gives me $427.50. And for 9.5 hours, it does say that he charged $427.50. So my 3 values that are true are 6 hours and $270, 8 hours and $360, and 9.5 hours and $427.50. And we figured that all out because we figured out how much he was going to charge per hour by taking the ratio of 225 for 5 hours, dividing 225 by 5 to figure out how much he charged for 1 hour of work. So $45 per hour. I took the $45 and then multiplied it by how many hours it said he worked for each different answer choice. And when we did that, we determined that those 3 were true. Evie, no, don't put in your email. Your user ID is actually the GEV. And then your password's whatever you made it up to be when you made the account. And I can reset it. Do you want me to reset it for you? Yeah, you got it. All right, I just sent you your new password in a private chat. Of course. All right, so back to the assignment. Okay, so we finished question 14. So now we will go on to question 15. So on here we have 2 triangles, figure A and figure B. The scale that maps figure A onto figure B is a scale of 1 to 7.25. Enter the value for X. All right, so this is when I talked about needing to know proportional relationships because of engineering and design, right? And I said if we want to design a building, obviously we won't have a piece of paper that's as big as a building, so we'll need to be able to scale it down. So this is essentially the same thing. We have 2 triangles. Figure A has one side that is equal to 3, right? This is figure A. Figure B for triangle. it has an X on that same side, but we know what the scale is, right? Scale tells us the proportionality of these two triangles. It is 1 to 7 1/4. When you see this in engineering, it will say like this is 3 feet or 3 inches, right? And so for every 1 foot, we have 7 1/4 feet. It's usually how you'll see it, which kind of makes it easier to correlate what you're looking at. So if I know that on figure A, I have 3 on this side, that means that I have, and this is my smaller triangle, so I know that 7 1/4 is going to be for this X over here, right? So this will be A to B relationship. So I have 3, and I need to figure out what my B will be. Here's A. Here's B. We don't know what it is quite yet, but we know that the relationship needs to be 1 to 7 1/4. If I have 3, what I need to do to get my 7 1/4 proportionally equal or equivalent, I need to take my 7 1/4 and multiply it by 3. And I'm doing that because I know that for every 1 foot, I need to have 7 1/4 feet over here. Does that make sense? Yeah? Okay, perfect. So I'm going to take 3, I'm going to multiply it by 7 1/4. And since I'm super good with fractions, so are you guys, I know that 1/4 is just like when I have a dollar amount, 4 quarters make 1 whole dollar. So I know that 7.25 is equal to 3 or 7 1/4. Multiply that by 3. 3 times 5 is 15. Carry the 1. 3 times 2 is 6 plus 1. So give me 7. 3 times 7 is 21. And then I have 2 numbers behind decimal points, right? I didn't put a decimal point. I didn't make it 7 times 3.0. So I only need 2 numbers behind my decimal place. So I'm going to go 1, 2. So my proportional ratio to make it equivalent to the 3 is going to be equal to 21.75. Okay? Or if you want it written as a fraction, 21 3/4, right? Because I know that 75 cents is equal to 3/4. Think about money-wise, if I have 3/4, I have 75 cents. So 21 3/4. So your value for X will be 21.75. So it's a lot easier than what it seems, right? You look at the problem itself. Good. Isaiah, I'm excited you have your camera on today. I feel like I know for sure someone is listening. All right, so we are going to move on to 16 unless somebody has a question. And Evie, did you get in?
Wait, what's the answer?
The answer was 21 3/4 or 21.75 right here.
Okay.
All right, so next for number 16, we have, oh gosh, Lisa wrote the expression 3 plus 6x minus 2 times, parentheses, x plus 1, in parentheses, plus 5. She simplified the expression using the following steps. Lisa says that parentheses 3 plus 6x minus 2 parentheses x plus 1 plus 5 equals x plus 6. Lisa's statement is incorrect. In which step did Lisa first make a mistake? And what is the correct expression for that step? So what we need to do essentially is figure out how to simplify the expression that we have to see where Lisa made a mistake. Earlier, I opened a state test, right, for a student, and I realized I never sent the link to the student that asked. I just put it in our chat. So that test closed. Give me 1 sec. Okay, there we go. There we go.
We can only see the little equation you did for number 15.
Okay. There we go. I'm going to go ahead and start number 15. Let's see, I'm going to write out the expression here. So 3 plus 6x. You guys see that lighter green? Or is that hard to see?
Hard to see.
Hard to see? Okay. Three plus 6x. And I have minus 2 x plus 1 plus 5. All right, so this is going to be kind of like an order of operations problem where we need to simplify our expression, right? There's no equal sign, so we don't have an equation. We have an expression, and we're going to just be simplifying. Oh, thank you, Evie. So I am going to, here's my PIM, which starts with parentheses. All right, so this parentheses 3 plus 6x, I have a variable in here. So I can't do any more math. I don't know what my value is for x, so 3 plus 6x, that's all that I can do mathematically. Cannot change it any more than that. All right, so next I have x plus 1. I have a variable in there, so I can't do the math for x plus 1. But I do have a negative 2 here that I can distribute through to get rid of my parentheses. So I have negative 2 times x. Then I have negative 2 times positive 1. That's going to give me negative 2x or minus 2x. Then I have negative 2x times positive 1, so that will give me negative 2. Right? From our rule, if we have a positive and a negative, we multiply them, we will always get negative. And then my plus 5, there's no math I need to do, right? There's no division, addition, subtraction right here. It's good. There's plus 5. Now I am going to combine like terms to simplify this expression. Combine like terms. And what that essentially means is if I have numbers with variables, I can combine those. I have integers here that do not have variables. So these are like terms as well, right? They're just plain old integers. So I'm going to rearrange this problem with my combined terms. So I have 6x. It's positive, so I don't need to carry its sign with me. I have minus 2x. Then I'm going to take all my integers. We're going to assume that this is positive, right? Because there's the negative sign in front of it. So I have a plus 3. I have minus 2. Then I have plus 5. So with 6x minus 2x, that will give me 4x, positive, right? Then I have 3 minus 2, which will give me 1 plus 5 will put me at 6. So I have 4x plus 6. All right, so now that we're looking here at, Lisa says that the 3 plus 6x parentheses minus 2 parentheses x plus 1 plus 5 is equal to 6x plus 6. Lisa's statement is incorrect. So in which step did Lisa first make a mistake? Let's see. So step 1, we have 3. It looks like she pulled out a 3, right? So let's see. If I take my 3 plus 6x and I pull out a 3, right? That's what it says here in this first step. If I divide this by 3 to pull it out over here, 3 divided by 3 is going to give me 1. 3 divided by 6 will give me 2. So it should look like 3 parentheses 1 plus 2x. But in my step 2, it has 3 parentheses x plus 1. So step 2 right here, we already have a mistake, right? Because 3 parentheses x plus 1 would give us 3 parentheses x plus 1 would be equal to 3x plus 3. So step 2 is already incorrect. Oh wait, that actually happened in step 1. Step 1 is incorrect. So now we move on to step number 2. 2x plus 1 plus 5. Did she change anything in step 2? Oh, she switched the x to 3x plus 1. Step 2, I suppose if you take what she had in step 1, it's not necessarily incorrect. So let's see, step 3. When she went to combine like terms, she combined x plus 1s without distributing the multiplication through. You guys see that? See how on step 2, she tried to turn the parentheses x plus 1, x plus 1, and combine those into essentially 1, right? 3 minus 2, 1 x plus 1 plus 5. But in order to make that correct, you need to actually distribute the x's, the multiplication through that. So you'd have 3x, and you'd still have negative 2x, but you would have plus 3, and then you would have plus 2. So for step 1, that is incorrect. Step 3 is incorrect. Let's see, so far, which ones do we have? A, A, 1 plus 3x. Oh, it's B, because we should have 3, 1 plus 2x. So here we go. Step 1 is incorrect, and step 3, because it should be 1 plus 2x minus 2x plus 1 plus 5. Does that make sense, you guys? And then I just saw that we are 2 minutes past class time. I do appreciate that everyone stayed. If you do not want to stay in, that is okay. Do you guys want to go over any more?
Yeah, I want to go over some more.
Some more? Okay. Let's keep going. So question number 17, which I realized I forgot to hit record, I think. Oh, wait, we're on question 16. No. Here we go. We did question 16. This is 16. The answer is B. All right, so question 17. Oh, we have a graph in here. There we go, question 17. So it says, the graph shows a proportional relationship between the numbers of hours the factory is in operation and the number of gallons of water used. Remember earlier in the year, or I guess earlier in the quarter, I've only been with you guys for a quarter, I told you guys the most important thing that you need to learn in 7th grade is proportionality. So the rest of these questions, I think, have a lot to do with proportionality and area. The area also has a lot to do with proportionality. So just forewarning you guys, we will have a lot of proportionality questions coming up. All right, so I have select true or false for each statement about the graph. All right, so let's read question number 1. It says the factory uses 4 gallons of water when it's in operation for 400 hours. All right, so 4,000 hours, okay. The factory uses 4 gallons of water when it's in operation for 4,000 hours. It seems a little backwards, right? 4 gallons of water right here. They have mixed up. If we look at our graph, it says number of gallons right here, right? 4 gallons used. So if I have 4, it's going to be like way down here. So it should be kind of the opposite, right? It should be 4,000 gallons of water used for 4 hours, right? Because right here, this is my number of hours. Let's see, hours in operation. 4, I would use 4,000 gallons. So question number 1, if you look at it just the numerical values, it looks like it could be right? Because it says 4 and 4,000. But it's opposite. It says 4 gallons of water is used when the factory is in operation for 4,000 hours. But it should be 4,000 gallons of water is used when the factory is in operation for 4 hours. So we're going to have false. Point W represents the number of gallons of water used when the factory is in operation for 7 hours. All right, so let's find W. All right, so according to the graph right here, I have hours of operation here across the x-axis. It says 7 hours, right? I go up, here's W. So it says point W represents the number of gallons of water used when the factory is in operation for 7 hours. So yeah, that's true. Right. This point here is on 7 for the x value, and it's going to be between 6 and 8,000 gallons of water. So for number 2, that is true. All right, so the factory uses 9,000 gallons of water when it is in operation for 9 hours. So what we need to do is we need to go over to our x-axis right here. Here's 9, meaning 9 hours. And then we see where the number line passes through the line here. That's going to give us our y value, right? On the y-axis. It looks like here, the number line, I wish I could draw on that, is going to be in between 8,000 and 10,000. And it does look like it's pretty much perfectly in the middle. Or we could even actually find the slope to get the exact right answer. But just by looking at the graph without doing any math, we can tell that in 9 hours, the number of gallons used is going to be approximately 9,000 gallons. So this is going to be true. And make sure you get really good at reading graphs, because next year you're going to have to take the SBAC in science, and you're going to have to be able to read a graph. I know, super fun. All right. Does everyone have question number 17 or any questions? I didn't write anything down. That's why there's no words here on the paper. I just showed you guys the answers. Can you guys see the mouse moving around when I share my screen? Yeah? Okay. Thank you, Isaiah. All right. So we are going to move on to question 18. All right. Okay, so the figure shown is created by joining 2 rectangles. Can you guys see the 2 rectangles? Thank you. Perfect. So I have, here's one rectangle. Here's my second rectangle. We're going to pretend like that matches the drawing a little bit better than it does. Switch to the paper. Okay, here's my two rectangles. So I've got 25 inches here, 25 inches here, 25. This is going to be 10 inches on the side. Then I've got 15. $75 and 15. All right, so it says enter the area in square inches of the figure. All right, so how do we do this, right? So we know that we are going to have to figure out the area of two different rectangles. What I'm going to do, make this easier on myself, I'm going to take the area of my longer rectangle. I see that this rectangle right here is going to be 15 inches here and then 75 inches here. And if you remember what the formula is for area, that is just going to be length times width. So right here, here's my length. Length is equal to 75 inches. The width is equal to 15 inches. And in the answer, it says enter the area in square inches. When you have something where it says answer in square inches, you know that your answer should be inches squared. And that should help you know that you are going to multiply these two together, right? That's the only way that you'll have the inches squared as your final answer. So the area for my first rectangle is going to be 75 times 15, right? Because here is the width, here is the length. If I look here, I have 25, 25, 25. That's also equal to 75. So I know that this is 75 here and this is 15 here because it's labeled. And I have all right angles, so I know that they're all matching. I would not have right angles here if these were different lengths or heights. So 75 times 15, 5 times 5 is 5, carry the 2. 7 times 5 is 35 plus 2. 0, 1 times 5 is 5, and 1 times 7 is 7. 5 plus 0 is 5, 7 plus 5 is 12. Carry the 1. 3 plus 7 plus 1 is 11. So I have 1,125 inches squared for my first area. But I have more. Okay, I'm not going to put that as my answer, right? Because I still have a whole nother rectangle right here I need to finish. All right, so the little rectangle right here, the side is labeled 10 inches. And the top is 25. I know I need to take the length, which this is equal to length, and multiply it by the width, which is 10 inches. So the area of the smaller rectangle is going to be 10 times 25 inches. Okay, 10 times 25. Okay, 0, 0. 1 times 5 is 5. 1 times, oops, I forgot to put 0. Sorry. 1 times 2 is 2. So I've got 0 plus 0, 0 plus 5 is 5, 2. I have 250. So that means that I have 250 inches squared for the little rectangle. I need to add this to my 1125, right? Because I'm trying to find the area for this whole rectangle, both rectangles, okay? So 1125 plus 250, which is squared. 5 plus 0 is 5. 2 plus 5 is 7. 1 plus 3 is 3. I'm sorry, 1 plus 2 is 3. Drop down that 1, so it's 1,375 inches squared. Right? Oops, sorry. I did all that math, but you couldn't see it. There you go. So our answer for number 18 is going to be 1,375 inches squared. And it says enter the area in square inches. So you don't need to type in inches squared. Okay, just 1,375.
Okay, do we have to put a point?
Mm-mm. Nope, it's a whole number.
Okay.
Because we didn't use any decimal points in here. Okay. If you were to put 0.0, it won't mark you incorrect because it's technically the same value. Just FYI. But you don't need to put it. Because we didn't use any numbers with decimal points. And I'm not going to be strict on significant figures. So I don't think you guys have had to learn that yet. All right, are we ready to move on to number 19?
Yeah.
Okay. Question 19. Alfonso went to famous Sam's appliance store and purchased a refrigerator and a stove. The sale price of the refrigerator was 40% off the original price, and the sale price of the stove was 20% off the original price. Which statement must be true to conclude that Alfonso received 30% overall discount on the refrigerator and stove together? All right. So what we need to be able to see here, we're going to have fun with the algebra. Ready? The sale price of the refrigerator was 40% of the original price, and the sale price of the stove was 20% off the original price. So we talked about this a little bit when we were doing the iReady practice test. Question number 19. So we need to find the relationship that we can make. And we are going to make an inequality to figure this out. All right, so we have the sale price of the refrigerator was 40% off the original price. So we're trying to figure out what the overall price was for the refrigerator. If I get something on sale for 40% off, that means I'm going to pay 60% of the original price, right? 60% of the original price. Because if I have my price at 100%, I got a 40% discount, meaning I take off 40%. I am left paying 60%. So let's keep that as R for refrigerator. Thank you. So I'm going to have R here. And remember, to turn a percentage into a decimal point, that means I have 60 out of 100. And when I divide that, that's just going to give me 0.6, right? So I'm going to be paying 0.6 of the original price of the refrigerator. So 0.6 R. Now let's figure out what I paid for the stove. It said that I paid, I got 20% off, right? So the original price was 100% of the value. I got 20% off. So that means I have 100%. I took 20% off for the sale price, meaning I paid 80%. I paid 80% of the original price. Okay, so that's going to be equal to 80 over 100. So it's equal to 0.8. So I have point plus 0.8 S, right? So it's the stove. So which statement must be true to conclude that Alfonso received 30% off the overall discount on the refrigerator and the stove together? So this means I'm gonna have to throw in a parentheses, right? Because what I want to know, or what I want to make my problem here, my expression equal to, is 30%. It's an overall discount, and 30% turned into a fraction. Let's see, it'd be 30 out of 100, right? Parentheses, right? Because it's going to be the total of the refrigerator, R, this R plus S, right? And those are going to be the original values because he wants to know that he got the overall discount of 30% of R plus S. So the sale prices of the refrigerator and the stove are the same. Well, that's impossible, right? Because we have 0.6, we paid 0.6 for the refrigerator and 0.8 of the stove. So the sale prices of the refrigerator and the stove are the same. We don't really need them to be the same. So the original prices of the refrigerator and the stove are the same. The sale price of the refrigerator was twice the sale price of the stove. The original price of the refrigerator was twice the original price of the stove. All right, well, with the problem that we have thus far, we can't figure out what the answer is going to be yet, right? So let's go ahead and we'll distribute this through our parentheses, right? Okay, and let's just go ahead and put 0.3, so that way we know I have 0.6R plus 0.8S is equal to 0.3 R plus S. 0.3 S. Okay, so what I need to see here, the sale price of the refrigerator and the stove are the same. The original price of the refrigerator and the stove were the same. Let's see, if I put in here, I have 0.6 of R and 0.8. So if I divide my value here, my R plus S, because I'm going to need to get this essentially by itself, right? If I have 0.6 R, 0.8 S, I can't take that away. I can only get rid of my 0.3. So if I do 0.3 here, right, that gives me R plus S by itself. So I have 0. Actually, hold on. I'm going to have to divide. So I have 0.6 and I'm going to divide that by 0.3. That will give me 2, right? So I have 2R plus 0.8 divided by 0.3. It's going to be 2.67 S. So they're going to be close in price, right? It's going to be equal to R plus S. which is the price of the stove and the refrigerator together. So the original price of the stove, the original prices of the refrigerator and the stove were the same. The sale price of the refrigerator was twice the sale price of the stove. That's close, right? The original price of the refrigerator was twice the original price of the stove. Well, I know that the stove, in order to get the original prices, I have 2 and 2.67, right? So the refrigerator, the stove is actually more expensive than the stove. So the sale price of the refrigerator was twice the sale price of the stove. The original price of the refrigerator was twice the original price of the stove. We know that these aren't the same. Sale price, the original price of the refrigerator is twice the original price of the stove. So if I have 2R 2.67 S, that is my new proportion for R plus S. So the original price of the refrigerator has to be less. So the sale price is C. The sale price of the refrigerator was twice the sale price of the stove. Oops, sorry, you guys. I don't have my math there. And the reason why I know that the stove, the price of the stove was larger than the price of the refrigerator is because I have to multiply the stove by more to get R plus S. So that means that the refrigerator cost more with the sale price. Does that make sense?
Yeah, I actually got
Yeah.
that one right.
Oh, awesome. Good job. That's exciting. Oh. All right. Sorry, the other teachers are coming in. They're giving out the awards. I might have to go in a minute. Let's see. Should we do number 20? Select all tables that represent a proportional relationship between X and Y. Oh, so we have to pass out the awards to your homeroom teachers, so that way you can collect them from your homeroom teachers. I kind of want to keep mine so that way you guys have to come see me. All right. Do you guys want to do number 20? Or is there one in particular that you guys want? Okay. So I need to get our awards organized. All right, select all of the tables that represent a proportional relationship between X and Y. So when I have a proportional relationship, that means that if I have, here's X, here is Y, and I need to be able to identify a pattern that is proportional. It means it goes up or down by the same value, right? That's consistent. So I have, for my first one, I have, let's see, 0. I have 1/5. Then I have 2/5, 3/5. And I can see here that my values are increasing, right? I have 1/10, 2/10, and then 3/10. So I can see that as I go up in value, I add 1/5, right? If I add another 1/5, right, that gives me 2/5. So as I increase with my X value, I add 1/5. My Y value, I'm going to add 1/10, add 1/10, add 1/10. So that one does have a proportional value, right? So for every time I increase in the x, I go up 1/5, and then for each value I go up in y, I go up 1/10. So that means I have a relationship of 1/5 over 1/10, right? Or 0.2 over 0.1, right? So that's a relationship that I can identify here, and it's consistent, right? It stays the same. So you're going to mark the first one. Just click on it. Yeah. Okay. So select all tables. So my next one, I have X and Y. For the X values, right, I have 0, and I have 1/5, 2/5, 3/5. All right, and my next row, or my Y row, I have 0. Then I have 1/3, and I have 1/4, and then I have 1/5. All right, so I see here that I'm going to add a fifth. I add a fifth. Add a fifth. All right. So there's a pattern here for X, but let me check. Do I have one that is consistent for Y? All right. So I added a third here. That's 33% or 0.33. My next one is a quarter, right? So, what did I do there? 1/3. I kind of like added one to the bottom, right? Maybe I could have like X plus 1, and then I went to 2/5. So I don't see a pattern here, right? Nothing that is similar to X. Because I could have a proportionality of like, I have 1/5 to like negative 1/2, but I'm not going and I'm not reducing my numbers by anything that's consistent, right? I'm just going from 1/3 to 1/4 to 1/5. So there's no proportionality here for the second one, right? And 1/3, 1/4, 1/5. I can't find a pattern that is consistent to create a proportional relationship. So if I was to graph it, I wouldn't have a graph that like has a significant slope. It's going to vary. Okay. Let me check my next table. I have X. First value is 0, 1, 3. Next one is 5. Okay, then Y. Okay, for Y, I have 0.
You're muted.
I have a teacher's asking me a question. All right, so I have 0, I have 1, 3, and 5. All right, so what I have from 0 to 1, I have +1. From 1 to 3, how did I get that? I either have +2 or I have -3. To get to 5, I have +2. Okay, so far my pattern is +2, but it wouldn't make sense for my +1, right? So right here, I have +1, then I have +8, +16. All right, so I don't have a pattern here either, right? I do have, let's see, 1 to 1, that's whole, and then 3/9, that's 1/3, then 1/5. I don't have a pattern here, right? All right, so then I have X and Y. Zero, 1, 3, 4. Then for Y, I have 0, 5, 15, and 20. All right, if I look here, I have +1, I have +3, or in between these two, I have +2, +3. All right, I'm not seeing anything right here, right off the bat. Over here, I have +5, +10, +5. Let's see. I don't have 2 here. Let me see if I can find something with the 1/5, 3/15, and 4/20. If I take a simplified 3/15, let's see, if I divide 3, that is equal to 1/5. Right? If I simplify this, I have 4 divided by 4 equals 1. 20 divided by 4 is equal to 5. So my proportionality is 1/5. So my last number, or my last table here, is also a table that has a proportional relationship between X and Y. It would be 1 to 5 here. Does that make sense? Yeah? All right. So it is now 12:30. I'm going to make sure that I have all of your rewards prepared and sent over to your teachers.
Okay, really quick, what do we get for number 14?
For 14? Let me see.
Yeah.
Where's 14? 14. Oh, that was a bunch of them. 6 hours and $270.
Okay.
8 hours and $360.
Okay.
And then 9.5 hours and $427.50. That
Okay,
is.
thank you. Also,
Okay.
do you think maybe when you're done with the rewards, you can help me on a private call?
Yes, but it might not be until like 4 or 5.
Oh, okay.
Is that okay?
Then I'll just wait till tomorrow then.
Well, okay. You can do that, but grades are due tomorrow. So make sure that you if you want to do it tomorrow, how would I message you when I'm done with everything? See what you're doing, and then actually, you know what? You are in my class tomorrow, so it's fine. That works.
Yeah.
We can do it tomorrow. Okay.
Okay, thank you.
Yeah, of course. All right. Bye, Brody. Thank you. All right. Bye, everyone. I'm going to go ahead and end the meeting.